Beep, boop, over. Today's objective is pretty straightforward. We're just going to complete the loop of our AI. So we're going to finish up the flow a little bit. The AI are going to work a little bit better and we're going to fix a few bugs here and there. But other than that, we're not going to add any other flashy stuff. So let's get to it. So in Unreal, the first thing we're going to do is start by opening the BP unit AI. So here it is. And in between the videos, I noticed a few weird behaviors still happening with the AI. So we're just going to start by fixing that. The first one is related to the movement of the unit when it tries to cast a spell. I think the value of the initial cost is still a little bit too small actually. So I'm just gonna go here in my calculate the spell score and update, and I'm gonna zoom right here. We are calculating the default total spell score based on the amount of tiles we want to move to cast the spell, and this value is still too high for my spell damage because my spell damage are not that high, so it doesn't work that well. So what I'm gonna do is just add, let's say 30 right here. So minus 0.0001. That way, this value should not be an issue for us anymore. But as I said before, you can play around with this value and put the value that is the best for your game. In my case, my damage are very small right now, so I'm putting a very small value. But maybe you want to have a bigger values, I don't know. Okay, so that was the first bug. The other one is for the pathfinding when we are trying to find which tile is the best at the end of the turn. So I'm gonna go in my pathfinding and inside the find farthest index right here. I think that right there we are using the diagonal if we want to use a diagonal or not in this get minimum cost between two tiles. But I actually realized that using the diagonals in this calculation right here doesn't give me the right result. Actually not the result that I want. I don't feel like my units are going at the right location on the grid, and I think it's a little bit better if we are not using the diagonal. So I'm just going to delete that bit of code right here and never use the diagonals in this calculation right here. But same thing as the other bug, if the previous logic was better for your game, you can just keep it. It doesn't really matter as long as the units are moving properly on the grid. But anyway, that's it for the two improvements I wanted to do on the AI before starting to do the real work. So now we can jump into the real work, which is the AI flow right here. And we can see in this graph that it's not really pretty. We didn't work on that graph that much. We worked a lot on the enter movement. As we can see, we worked a lot on the spell casting, obviously, but we didn't work on the AI flow at all. So we're going to clean that up a little bit and make the flow a little bit better. And also, before we start doing that, I'm just gonna go back in my enter movement. We have a little bit of code right here that is a little bit disconnected from everything else, and it is the decide where to enter underscore done. This part right here, I'm going to move it back inside the AI flow. So I'm just going to cut this part, go back in the AI flow and paste it, let's say right here. It doesn't really matter because we're going to shuffle things around a little bit. And actually, we're going to do that right now. So, okay, we start right here. The AI starts right here. We decide which spell to cast, which in return is going to call this event right here. So just to make it clear, I'm just going to align it afterwards. So decide which spell to cast, continue right here with the event. Then we're going to check if the spell is valid. If it's valid, we're going to try to cast the spell right here. So that's good. Otherwise, we're going to end our turn. And then we're going to continue right here. So when we are trying to cast a spell, we're going to move to the spell casting location, which is in return going to call this event right here. So I'm just going to move the event afterwards. That way it's super clear. Here we go. So the flow goes right here in a straight line. Once we're done casting the spell, it's going to call the spell casting done right here, which is going to end the turn. For now, it's good enough. We're going to tweak that a little bit in a few seconds, but for now, let's keep it that way. We are deciding where to end our turn, which is going to then call this event right here. So I'm going to move it at the end, just so it's clear. Let's keep it a straight line like the other ones. And then it's going to move to the end turn location, which is the bit of code that we have right here. So I'm just going to move it at the end like that. There we go. So that's a little bit more clean than what we have before. The AI starts right here. It decides which spell to cast. Once it's done, it's going to check, okay, is the spell valid? If so, it's going to cast a spell, then move to the end turn location and stop its turn. Otherwise, we're just keeping the spell casting and go directly to the move to end turn location right here. But we didn't change anything yet. Everything is the same as before, it's just more organized. So good. But did you notice the problem in the flow? At the beginning of the turn, we are trying to find a spell, we are casting it, and then we are ending our turn right away. But what if the unit is able to cast multiple spells during its turn? Maybe it's going to be able to cast 2 spells, 3 spells, 5 spells maybe. We don't want the unit to skip its turn before casting all those spells. So what we're going to do is, when we are done casting the spell, we're going to check again, okay, do we have another spell that we want to cast before ending our turn? So I'm just going to move my spell cast done right here at the end, and instead of connecting it to the decide where to end turn, I'm going to reconnect it all the way at the beginning right here, decide which spell to cast, and then I'm just going to add myself a few reroute nodes just so it's a little bit cleaner and it's more obvious what's happening. So here we go. So now, once we're done casting the spell, it's going to go back all the way at the beginning to try to find another spell to cast. And then, okay, it's going to check, okay, is that second spell valid? Yes, okay, cast it. So it's going to cast the spell again. And then it's going to go back at the beginning, decide, okay, do I have a third spell I want to cast this turn? Is it valid? Yes, no, yes, oh, okay, sure, cast it again. And then go back at the beginning, decide which spell to cast. Oh, do I have a fourth spell to cast? Is it valid? No, okay, I can end my turn now. So I'm just going to move to my end turn location right here and then end my turn. Good. So that's the first challenge we wanted to do, and now it's going to allow the unit to cast multiple spells during its turn. So let's go try if it worked. Here we go, so here I have my warrior and my ranger on the grid. The ranger is an AI, so if I skip my turn, now the ranger should attack me at least once, okay? Then move, attack me a second time before ending its turn. Here we go, so now the ranger is able to attack me twice before ending its turn. If I skip my turn again, the ranger attacks me once, twice, move again. Here we go, and my turn again, we can see that it works over and over and over. If the ranger is able to attack me multiple times during a turn, it's going to do it, and that's what we want. We want the unit to use all their action points before ending their turn. Good, that works. Okay, now we can stop, and then we're gonna go back in the unit AI. And now that we're done with the flow, and the flow is working perfectly, what I'm gonna do is just a little bit more cleanup. It's just a preference. You don't have to do it if you don't want to, but what I'm gonna do is just move all the macros, the set AI state with delay, inside this graph. Because right now, if we do a fine reference, right here, we can see that they are a little bit everywhere. They are inside the enter movement, inside the spell casting, and also inside the AI flow. And what I want is just to move them all inside this graph right here. So before deciding which spell to cast, we're going to set the AI state to decide which spell to cast. Then before moving to the spell casting location, we're going to set the AI state. Same thing for that one and the other events. So first I'm going to go in the other graphs to delete the other macros. So I'm going to go right here in the decide where to enter and start by deleting this macro. So I'm going to delete that one. Then I'm going to go to the next one. So this one right here, delete it and reconnect the flow, obviously. And then go in the spell casting to delete the macro, reconnect the flow. Go in the other one, delete the macro, reconnect the flow, and finally go in the last one right here, delete the macro and reconnect the flow. Here we go. So now if we compile and do another fine reference, we should only have 2 macros inside the AI flow. So now we can go back in the AI flow right here, and now we're going to recreate all those nodes before all the function calls. So I'm going to duplicate that one, change the AI state to decide which spell to cast. I'm going to move my code a little bit on the left to make myself a little bit of room, and then I'm going to connect it right before calling the event right there. Here we go. So we are setting the state and then calling the event, and we're going to do the same thing for all the other ones. So I'm going to copy my macro once again. I'm going to paste it right here in between, right here also. I'm going to paste it right here and right there. Here we go. At the end, we don't have to paste it because it's already there. So now I'm just going to reconnect all those together. Here we go, so that's how it looks. Here at the beginning we can see that we have the decide which spell to cast, then we are calling the decide which spell to cast event. In the middle we're doing the same thing, so move to spell casting location, move to spell casting location, decide where to enter and decide where to enter, cast spell, and then we have the move to enter location and then calling the event move to enter location. And at the end we still have the enter as before. Here we go, so now we can just go see real quick in the game to make sure that we didn't break anything. So here is my grid, I have my units, and if I end my turn, they should play as before. So my ranger is moving, attacking me twice, and then running away. This other ranger is playing, it's going to attack twice also, and running away. The priest is going to move, the other priest healing himself, moves. Okay, so we didn't break the logic, it seems to work as before, so that's good. That's what we wanted, we didn't change anything, we just reorganized a few functions here and there. But now I think it's time to look at one of the major bugs we have, and I think you probably saw that bug before. If you played around with the game a little bit and if you tested a few times, maybe you just ended up like ending the combat while the AI is playing, and that's what happens. Right now it caused an issue. Okay, it wasn't too bad this time. Oh wow, I'm surprised. But let's say I'm going to start again. I'm going to let the AI play and then end the combat while the AI is playing. Okay, that was better than I expected. Again, wow, that's surprising. Okay, I'm just going to try again, one last time. Just try to stop the combat. Okay, now the AI plays its turn while the combat is over, and then it goes to the next AI. Okay, yeah, that's what I wanted. Now the next AI is playing, the next AI is playing again and again and again, even if I'm not in combat anymore. Like, I'm not in the combat, and now I can move my unit even if I'm not in combat. That's weird, and I don't have a way to end my turn because I'm not in combat. So that's pretty weird, and then it caused a bunch of errors in the log, and if I stop, we can see that, yeah, I have a bunch of errors here. And that's happening because the AIs are not aware that the combat is over. They are not even aware that that their turn is over. So they are still going with their logic. So they are casting the spell, they are moving to the end location, they are skipping their turn, then it's going to trigger the next unit. So the next unit is going to move to the target location, cast its spell, and its turn, and on and on and on. And that's why the combat logic is still continuing to roll, even though I'm not in combat anymore. And that's pretty bad. So what we're going to do is first go back in the blueprint unit AI. And what we're going to do is every time we are trying to do a new action, so here we are trying to move to spellcasting location, for example. At that moment, we're just going to check, okay, are we still in combat? Are we still playing the unit's turn? Because if it's now the turn of another unit for some reason or whatever, we don't want the AI to continue executing its flow. We want it to stop right away because it's not its turn anymore. So let's say we asked the AI to calculate a path. This calculation took, let's say, 2 seconds, but in the meantime, the combat was ended by the player or by something else for some reason. And now the AI is like, okay, I have my path, but what we want to do in that case is just tell it, okay, stop there. We don't care about the path anymore. The combat is over. So just don't do anything with it. And that's what we're going to do. So every time we are doing an action that takes a little bit of time, so let's say the delay that we have right here, or asking for the reachable, asking for the path, or things like that, we're just going to make sure once that action is completed, before going to the next action, we're just going to make sure, okay, are we still in the combat or are we still playing our turn? And to do that, we're going to create ourselves a new macro to help us. Here we go, so that's how it looks. It's super simple. I named it the stop flow if unit is not active. So if the unit is not active anymore, we're not going to do anything, and that's what I'm doing right here. If it's false, if the unit is not active in combat, it's going to be false, and we don't want to continue the flow, so I didn't connect it to anything. But if it's true, I'm connecting it to the output because we're going to continue the rest of the flow, which is the logic of the AI. And then right here on the right, I have my 2 variables, and then I've also set an instance color. You don't have to do it if you don't want to, but I think it's easier to spot the macro in the code if they are using a different color. So here they are a little shade of purple. Perfect. Now it's time to go use this macro to stop the flow and prevent the unit from continuing its flow when it's not its turn anymore. And the first place I'm gonna go is right here in the set AI state with delay, because we have a delay right here, and it's possible that while the delay is running, the combat was ended by the player. So what we're gonna do is just check after the delay, okay, am I still in combat, by calling our new little macro right here. So it's going to stop the flow if we are not in combat anymore. And since actually this macro is used a bunch of places in between every steps of our process, I'm just going to also call it at the beginning. So I'm just going to make sure before setting the state of our AI, okay, am I still in combat? Yes, okay, I can set my state. Then I'm going to call the callback, no problem, wait for the delay. And then after the delay, I'm going to check again, okay, am I still in combat? Yes, okay, now I can continue with the next step of the code. And that's how it looks once I've straightened up everything. So good, and we can see that with the purple nodes, it's easy to spot, so that's nice also. Good. The next place we want to call this macro is inside the delay if taking too much time, because there's a delay right here. And what we're going to do is simply call the macro at the end right here. So if the delay is triggered, we're just going to check, okay, is it still my turn? Yes. Okay, then I can continue with the rest of the flow. That's it for both those macros. Now it's time to go use this new macro everywhere we are hooking ourselves to one callback, because let's say we are asking a unit to move. The unit is going to take, let's say, 2 seconds to move. Once it's done walking, it's going to call the callback we are attached to, and then that's going to execute the rest of the flow. But if the combat was ended while the unit was moving, well, we don't want to continue the rest of the flow, obviously, so we're just going to use this macro to stop it right there. So let's go in the end turn movement, because that's the one we are talking about. And right here we have a callback. So I have a callback right here, so I'm just going to call my macro right here. I have a callback right here, so I'm going to do the same thing, and a callback right here, so I'm going to do the same thing. So I can use my macro right here, my macro right here, and my macro right here. And now I'm just going to reconnect them all and then make it a little bit clean, and then I'm going to show you the result. And here they are. So since they are purple, it's pretty easy to spot. They are here and here. And if I zoom right here on the callback, we can see that we receive the callback. We disconnect ourselves to the callback because that's normal. We want to do that still. And then we're just going to stop the flow right here if we are not in combat. Same thing for the other callback. So right here, I'm receiving the callback, I'm disconnecting myself from it. And then I can just call my macro to make sure that I'm still in combat. And at the end, if I go at the bottom, it's doing the same thing. So we are disconnecting ourselves to the callback, and then we can call the macro. Here we go. So that's it for the end turn movement graph. Now we're going to do the exact same thing, but inside the spellcasting graph right here. So same thing for all the callbacks. So I have a callback at the top right here. I can just call my macro right after disconnecting from it. So this one, then I can go at the bottom right here. We have a callback. After disconnecting it, I'm just going to call my macro, and then I'm going to go down. Same thing, after unbinding myself, I'm just going to call my macro, and then at the end, at the bottom right here, we have a delay. It's not a callback, but it's the same thing. We are waiting right here. So we have to make sure that after the wait, okay, are we still in combat before continuing the rest of the flow? So now I'm just going to reconnect everything, and then I'm going to show you the result. And here they are, so purple here, here, and here. And then if I zoom, we can see that I'm disconnecting myself from the callback, and then I can call my macro to stop the flow if it's not in combat anymore. Then if I go down, I have the same thing right here, so disconnect macro, and then at the bottom, I have my delay right here. So delay macro. That's all we needed to do to interrupt the flow, so the units are not continuing to play even though it's not their turn anymore, but there's still two last little things we have to do. And the first thing is that since we are just interrupting the flow like that, we're never going to set the AI state to something that makes sense. It's just going to be stuck to what it was before, and that's not really what we want. It doesn't really affect the game that much, but if we want to use that state somewhere else in the project later on, it might not be as stable as we want. So let's make it stable for now, since we are already working on it. So since we are stopping the flow, we have to manually make sure that the state is set back to, let's say, end turn, because that's what we expect it to be at the end of the turn. So to do that, I'm going to go back in the event graph right here, and I'm going to hook myself to the moment when the unit becomes inactive. And when that happens, we're simply going to set the state of the AI to end turn right away, because the unit is not active anymore, so the AI should be ending its turn. So that's what we're going to do as soon as it happens. And that's how it's going to go. So in the begin play, when we construct the AI object, we receive a unit, and then we can hook ourselves to the ununit active in combat change. So when the unit becomes inactive or active in combat, we're gonna know, because it's going to call this event right here. And in our case, what we want to do is that if the unit is not active in combat anymore, so we are checking if the unit is active in combat. If it's false, well, we just want to end the turn of our AI, so we can just set the AI state to end turn, and then call the callback to notify the rest of the game that the AI has stopped its turn because the unit is not active in combat anymore. So the AI turn is completed. So now the game can adapt itself if it needs to. And now the last thing we have to do is in the combat system. So let's go in there. So in combat, open a combat system. And right here, we are never deselecting the active unit when the combat ends. So we have to do that. Otherwise, it's not gonna work. And the AI is gonna still continue thinking that it's still its turn. So that's not good. So in finish combat right here, when the combat ends, when we are clicking on the end combat button, we're finishing the combat. But before doing that, we're just going to deselect the active unit just so the AI doesn't continue playing. So I'm just going to add myself a little sequence right here. So sequence to deselect the AI first if it's valid, and then we're going to call the callback as before, and to deselect the current unit, we just have to do that. So if the current unit is valid, we're gonna make sure to deactivate it in combat and then set the current unit to invalid, because there's no current unit anymore. We're not in combat anymore, so we obviously don't have any current unit. That just makes sense. And then in the end combat right here, we were already setting the current unit to nothing, but since we are already doing it in the finish combat, I don't think we need this one right here. So I'm just going to delete it. That way it's going to be a little bit more clean. We don't actually need to remove it. It's not going to break the game, but I think it's a little bit more clean if it's not there, if it doesn't need to be there. Good. Okay, now we can go test and see if it works. So I'm just going to add a unit on my grid that is not an AI and a bunch of AI. So, and then another bunch of AIs. Here we go. And now if I start the combat, I can end my turn, and now at any point while the AIs are playing, I can reduce the delay and stuff like that, and then I can end my combat. Here we go, end my combat. Okay, did it break anything? No, the AI are still back to their original place and they are not playing anymore. That's good. Let's try again. End my turn. Then the AIs are playing a little bit. Let's just wait. And then end my combat. Okay, the AI stopped right away. That's good. Try again. I'm going to increase the delay this time because that delay is also part of the problem. So let's increase it. Let's just wait for the AIs to play their turn. That one's attacking me, looking for a spell, things like that. Then it's trying to move. Okay, I'm just going to end. Okay, now it stopped moving. Here we go. It stopped right there. Good. We can start again, try again, and then end my turn. Wait for the AI to play its turn, making sure that it doesn't break anything. Okay, here we go, and then if I end my combat, let's say now. Okay, it seemed to work. The AIs are now back to normal, everything is good as expected, and that's working perfectly. So now if for any reason the combat ends while the AI is playing, it's not going to break the game, and same thing if the combat system for some reason tries to skip the the AI's turn because, I don't know, the unit died or something like that, it's also not going to break the game because the unit is not going to be active, so it's going to interrupt the flow. But actually, I just saw one problem that I didn't see before. Right here, we can see that the last bracket at the end is there twice because we are calling the end turn twice. We are setting the AI state to end turn twice. It's already in end turn, and then we are still calling end turn right here, and then we are still calling the callback. So that's not good. So we're just going to add a little check right here to make sure that we are not already ending our turn before setting this variable to end turn. And otherwise, it's just going to execute the code twice, and that's not what we want. And that's how it looks. So right here, we're simply going to check if we are not already in end turn before setting the state back to end turn and then calling the callback. Good. Okay, so that's done. Now we just have two last little improvements that I want to do. It's just to make it a little bit more stable, and that's gonna be inside the spell casting tab right here. And it's simply adding some extra condition to make sure that the spell is valid before trying to cast it. So right here, let's say in the move spell casting location, we are checking if the unit has to move, so if the indexes are not the same, but we're never checking if the spell is valid before asking the unit to move. So what I'm gonna do is just check the is valid right here to have access to my variable, and I'm going to add an end node in between right here. So if the spell is valid and the unit has to move, then we're going to ask the unit to move. Otherwise, we're not going to ask the unit to move because the spell is not valid. And same thing, if I go at the bottom, so I'm just going to zoom out and go here in the cast spell branch, we're trying to cast the spell, but we're never checking to see if the spell is valid before trying to cast it. So that's not good. I'm just going to add a check right here at the beginning. So is the spell valid? Yes. Okay, we can cast it. Otherwise, we're not going to cast it. We're just going to call the cast the spell done because we're done casting the spell doesn't exist, so let's not cast it. So that's it, that's everything I wanted to do in the unit AI for today. So that's pretty good. The AI is now way more stable than before, and you can stop the combat while they are playing, so that's a big bonus. Yes, okay, good. But now, since the video is a little bit short, I think I'm just going to add one little extra feature inside one of our debug tabs just to make it a little bit more fun, and then we have like something extra to show because right now we don't really have something different than the previous videos. So in my debug menus, in my tab, I'm just going to open the tab console command. And here it is. So I have all the previous command line that we added in it and a little bit more because I wanted to have some extra debug info while I was testing. And now I'm just going to add one extra row of buttons, and the extra row of buttons is going to be the SloMo row right here. So I have 4 new console command button right here. I have the SloMo 0.5, SloMo 1, SloMo 5, and SloMo 100. I don't think it can go to 100, but anyways, for all those buttons, we have the console command right here. So we have the SloMo 0.5, SloMo 1, SloMo 5, and SloMo 100 right here. So when we click on those buttons, it's going to execute the console command. So let's go see in game how it looks. Here we go, so here I have my units, and now if I start my combat, we can see that they are playing their turn as usual. We didn't change anything, so that's good. Now if I go in my commands, and let's say I click on SloMo 0.5, we can see that, okay, they are moving slower, they are taking more time to think, they are moving really slowly, and they are casting their spell probably slower. Yeah, here we go. And now if I click on 5, we can see that it goes a little bit faster. It works pretty well. Now all the units are playing way faster, and then if I click on SloMo 100, we can see that they are playing super fast now. There's just one thing though, the numbers on the screen, they are not playing at the same rate as everything else, because we can see that, yeah, the units are playing like super fast and they are animated super fast and everything, but the numbers are not at the same speeds for some reason. So we're just going to adapt the animated number a little bit just so they are matching the same play rate as the rest of the game. So okay, I'm just going to end my combat, and yeah, we can see that it remains even after the combat. Now all the animations are playing super fast, and that's pretty nice, but we can make them slower if we want to. There we go. So now I'm just gonna stop, and we're gonna go change the animated number. So I don't know where it is anymore, so I'm just going to search for it, animated, and open the W animated number right here, and I'm gonna go in the graph where we are playing the animation. And actually here we don't have much to do, we just have to change the playback speed of the animation so it matched the global time dilation, so the speed of the game. So here I'm taking my animated number animation, I'm just setting the playback speed, and I'm using the get global time dilation, which is the speed at which every actor in the game is already moving, or at least the speed at which they should be moving. I don't know why. It seems to apply the global time dilation to pretty much everything in the game, which makes sense. That's the purpose of that variable, but it doesn't really apply it to the widgets animation for some reason, so I don't know why we have to set them manually like that. Anyway, it seems to work if we do it manually. And in the case that this is just an engine bug and they fixed it in the future version, which I don't know, in the case that the animated number are already playing at the right speed on your side, you don't have to do that, otherwise it's just going to multiply it even more. So don't do it if it's already good, don't break it. But otherwise, that's how you fix it if the problem is still there in the version you're using. Perfect, now we should be able to test everything together. Here we go! So now I have all my units on the grid, they are fighting as usual, and if I speed up the game a little bit, we can see that now they are fighting faster, and also the animated numbers are playing faster also, and same thing if I play it 100 times faster. Here we go! We can see that the animated numbers are like super fast, so that's good, seems to work. Should also work in slow motion. Yeah, the animated number are slower, same thing as all the animations. Good! We can see that it works, and now the AIs are way more stable than at the beginning of the video. So that's great. In the next few videos, we'll still continue working on that a little bit. We're going to create some different AI behavior based on the different units types. I'm not going to do many of them because I don't have any ideas. But if you have any ideas of any designs for all the specific units, let me know. And then we might integrate that in the future. But for now, that's it for today. And I'm gonna see you in the next one. So bye bye.